Okay, cool. So I'm here to talk about nailing infrastructure as code using Terraform and Git. My name is Adam Wilson. I work for Cisco within the cloud calling, which means that I do some of the stuff that goes into the back end of WebEx Teams that very soon will let you call out to make regular phone calls via WebEx Teams. Some of the specifics of the rest of it is quite sort of low level. It's probably only touched by our engineers. But anyway, none of that is important for today. So roughly about 2 years ago, this was the breakdown of how I used to spend a lot of my time. There was a little bit of scripting, quite a lot of Bash, a bit of Python, a bit of Ansible. That green right at the top there is probably just generic faffing about. And the big green part is faffing about on the various cloud console UIs and what have you. In terms of like the team that I was working on at the time, we had one massive mono repo with all of our scripts in, and we would just sort of copy and paste from the GitLab UI into Vim and just run like that on servers. This is not what to do, by the way. Don't do this. And yeah, everything else was kind of stored randomly in /opt or on people's hard drives, and a lot of the stuff that we were deploying was still being deployed by clicking on the UI, which kind of worked for us at the time because we weren't doing anything complex, and we were kind of very gently moving between cloud providers, and it was where we were right then. Nowadays, my time looks a lot more like this, with all of the purple, various different kinds of, you can't really read the text there at all, but basically all of the purple is faffing with Terraform in various different, some of it's swearing at Terraform, some of it is getting along with Terraform quite well, but that's basically what's happened. There was a lot more of my time is spent on this one specific tool. And why is that? So within Cisco, we've got this big push towards how do we run modern services and keep all of our clients, keep all of our customers happy, keep sales opportunities coming in, and adapt to market opportunities. And modern services need to be available, they need to be secure, they need to be accessible, and upgradable. Upgradability, I don't know if that's a word, but it is now. And that's a big part of one of the reasons why I've become so enamored with a thing called Terraform. And I'll hopefully explain a bit more about how it helps us to kind of do some of this stuff as I go along. But it all kind of comes together, creating modern services by bringing beautiful code together with beautiful systems. Everything's running quite nicely, and we're all having a good time. So, as we're at a DevOps event, I thought I'd have a quick refresher on what DevOps is, because I'm assuming I'm the only one here who knows. Anyway, so that's the classic one at the top, is we don't want any snowflake environments. No one ever wants to hear, but it works on my machine, in my cluster, on my container. I don't know why it's not working for you. Ops are stupid. None of that stuff. We want to be able to optimize for the downstream. What does that mean? So if we're thinking about everything in terms of a production line, we want to optimize everything for the team that's going to take over what we're doing. So if we're working in dev, maybe you're optimizing for QA. QA, you should be optimizing for deployment into production. A concept called GitOps, about storing absolutely everything that we can into source code and storing it all in Git. I'm very, very quickly rushing through all of this because we've got a lot to get through, by the way. But we want to increase communication, increase the insights between different teams into what everybody's doing. We want to make sure that everything is still secure, and quite a lot of the time, especially in big organizations, that requires going through security teams or through a set of security teams and security processes. And wherever possible, we want to automate our testing. So that brings me neatly onto a thing called Terraform. That's the Google Trends. I don't know what that tells you. It's going up. People are still interested in it. So I think one of the things I wanted to highlight before I went too deep into anything else about how great Terraform is or how bad it is or whatever, it has to exist inside. This is why I've got space in the background. It has to exist in this kind of universe of technology inside your stack. It doesn't just work on its own, in my opinion. Anyway, you can get it to do quite a lot of stuff. It's quite clever and it's quite good at the job that it does, or depending on the providers that you're plugging into the back of it, the specific jobs that you want it to do. But in my experience, it needs a bit of help from things like Bash and Python to just get it to the point where you can get everything running quite sweet. And it's also helped a lot by things like Jenkins. So the reason why I've got the Let's Encrypt is that one of the providers you can also deploy. You can use Terraform to deploy things into GCP, AWS, DigitalOcean, probably even more, as I'm kind of talking to you about. Every time I look back at the Terraform providers page, they've updated it with more stuff. But the point of this slide is that it exists inside a sort of universe of technology, and it doesn't just work on its own. It needs some kind of helping hands. So that is a kind of important caveat to go around everything today. So what is see, again, you can't read any of the text on any of the, so I'm glad I spent ages taking screenshots of GitLab. But anyway, that's what it looks like if you haven't got your glasses on. So it is, like I said, it can be very powerful. You can get to the point where you can deploy your entire complex infrastructure, for multiple clients, for multiple environments, all in one command. That might not be a Terraform command. You could do it all in one command, but at the same point, you could probably also destroy everything with one command. So, if you start playing with this quite a lot, we've all lost DB servers now and again. They just disappear. It can, unfortunately, in sort of comparison to some of the other infrastructure as code tools, it will, especially when you're quite new with it, error out with things half deployed, which can be a massive pain. It's, again, one of the reasons why I'm going to recommend some of the things I recommend later on, is because sometimes the easiest thing is just to say, right, okay, it's not working, nuke the lot, and we'll redeploy it, which is doable if you've got things organized. It's not doable if you are trying to do everything in one directory, because you'll take DB servers out again. There's a thing called Terraform State. So the way that Terraform does what it does, so Terraform is primarily used for deploying cloud infrastructure. Again, it does quite a lot of other things, but its kind of primary role is for deploying VMs, load balancers, routes, firewall rules into things like GCP, AWS, DigitalOcean, and it is a declarative tool. So it will look at your configuration that you've built, it will look at its state file, and it will compare the two. It will build the state file out of its own configuration. So what I'm saying there is, if you've gone onto the UI and played around and added and deleted things, Terraform might not know everything it doesn't actually have a good understanding of what your infrastructure is unless you give it that understanding. So you could quite often end up with things going a bit wrong if you're not really careful about what's going on with your state file. And if your state file breaks, Terraform will just become useless to you. So it's imperative that you make sure that you are always able to roll back the state file after every change, which is really easy. If you just follow their documentation, store it all in an S3 bucket or in the GCP equivalent, turn versioning on. But if you're doing anything else with it, you need to make sure that you've got that covered. And another big one is keeping everybody in your whole team on the same version, because if anybody tries to do a secret little brew upgrade and they bump their version to Terraform before the rest of your team does, then again you'll break the state file because it won't let it then be updated by a previous version of Terraform. Anyway, I'm telling you why not to use the thing that I'm just about to talk about. Mostly because it is super cool when you first start using it, and you get really, really excited. If you're like me, you get really, really excited. You're like, oh my God, I could do all this stuff. But you've got to make sure that you've got these things covered. But none of these are insurmountable, and you can make your life so much easier if you just learn from my mistakes and don't do what I did. This is a massive pet peeve of mine, especially when you're working with primarily with Americans or with people that are in a totally different time zone to you, because you're looking at the Terraform, you're looking at the infrastructure that's deployed, and it doesn't match, and then you're screwed. And you've just got to wait till they wake up. But that is a big thing. Anyway, when you're writing Terraform, and I should say, so Terraform is written in HCL, HashiCorp Configuration Language, I think it is. But you'll be spending, it's basically JSON with like super simplified. It's like curly brackets with some key values. You'll be spending most of your time looking at this page or versions of this page. It's the documentation. Because of the nature of the beast in terms of like building things for the cloud, everything kind of works in its own sort of funky way. If you start using the same resources over and over again, you'll probably learn some of the documentation, but there's just too much there. So generally, you'll spend a lot of your time staring at pages like that. It's, no bad thing. Okay, enough about how bad Terraform can be. So Git. That is Git. So a couple of different things about what Git is. Hopefully most people here are familiar with Git to some degree. Source code management system. Linus Torvalds built it, and it was considered pretty handy that he did. This is your kind of standard, I don't know how to do the thing. Oh, there you go. So your standard kind of workflow would run from like the top to the bottom. You'd either init or a clone, and then change your branches, do commits, push, or rebase or merge. Or you might push force release if you're rebased. And there's some of these. I'm not going to go into too much detail because I know I put all of this stuff on this slide, and then I realised I don't have enough time to talk about it all. But yeah, if you're interested, read the documentation on Git. And get used to using it. Some suggestions about using Terraform and Git together. I would say use standard semantic versioning. It's really useful if everyone can just double check and sort of do their own research, read the documentation that's already out there, and don't try and be too clever with your versioning of things. And that ties into the fact that you'll want to use tags. If you're not sure what tags are, they're basically a sort of special name you can give to a commit in Git. That means like this is like version 1, this is version 2, or you could call it, this is deployment. You could call it what you like. But yeah, whatever you choose to call it, use tags, and I would suggest using standard semantic versioning for those tags. If you can, if your IT team let you tie the authentication and your groups in your Git server to Active Directory, just make your life easy. I would suggest if you want to kind of be open and DevOpsy about it, just give everybody read access to everything. But you might have to be a bit careful with things like push access. Use present tense in commit messages. It's just a cool little tip that I've recently found out that's a great way to, I never did, but it's a really good way of kind of saving yourself some characters. And set aside some decent time to do pull request reviews, because if you rush them, you end up with all sorts of terrible things happening. So pull request review, I don't know how much detail I need to go into with all of this stuff. Probably there's some people here that do pull requests all day, every day. And if I talk about them for too long, they'll get even more bored than they already are. But yeah, they're a really good kind of tool for training up new engineers, and for sort of making sure that everybody has just got a few sanity checks. In short, they're kind of like a before you're merging into what you might consider like into your master branch or into like the actual release. They're just a way of kind of getting other people's opinion and getting those opinions and the discussion sort of collected together in a searchable way. If that makes sense. So yeah, it makes more sense if you do them. And yeah, don't let anybody force push to master. That's a really bad idea. So I'm going to talk a bit about different branching strategies within Git. So it's source code management system. I'm not going to compare it to other things like SVN, but one of the great things about Git specifically is that you can branch often, and it's not a really big deal. Yeah, don't Terraform apply your feature branches at all. But yeah, there's some standard branching strategies out there, and this is one that it's good to kind of get your head around a bit, because so many other strategies are done in comparison to this. So this is Git Flow. It's quite often used just for like default application development. There's a lot of tools, like there's Maven plugins and what have you, that you can just start going, right, do my release branch, do my Git Flow for me, and they'll work out of the box, and they'll basically kind of build this model for you. You've got your sort of tags on your master branch down here. You got your develop branch, which tends to be a bit further ahead in terms of, it tends to be more, your experimental code that's in development. You've got feature branches that come off, you've got hotfixes, you've got release branches. All of this is so overkill for using tools like Terraform. Like, just don't, it's good to understand because you'll probably come across it, but it's overkill. This is one that I've come across that I thought you could potentially apply to a tool like Terraform. I don't myself, but I could see how it could work. Specifically, the GitLab documentation seems to say it's a good idea to use for iOS development. I've not really done any iOS development, so it's never really occurred to me. But anyway, the basic idea seems to be that you've got a different branch for your different environments, and you merge down until you end up in production. One of the things that they posit alongside iOS development actually is that if you've got a specific deployment window, so you need to have like a master branch, but you can only deploy to your specific environments at certain times because of your operations team or because it needs to go through some kind of change team or change approval team, then they suggest this. Your mileage may vary. Feel free, it's just I thought I'd put it in there for inclusivity. But this is probably the one I'd suggest is a smart move, especially for teams. I'd have to say most of the time that I've come into this, it's with operations teams who tend not to be used to Git as a concept, who are kind of quite new to it. And I've found that this is a really easy branching strategy to get together and get around. So you basically, when you create a new repo, you'll get a default branch, most often called master. And when you want to create a feature, you will just branch off of master, do your work there, create your feature. Maybe you'll open a pull request at some point in time. You'll chat with some of your teammates about and they'll be able to comment and feedback, and then you can merge back into master. And then everything is quite neat and it's easy to understand. Another thing, one slight caveat to that is I actually prefer to rebase just before I do the pull request, but it's not something that you might want to do if this is new to you or new to a team. Rebasing can get people tied up in knots, but it's really good once you get a bit more confident with it to just read some of the documentation on rebasing, just as a caveat there. Cool. So yeah, you can't read any of this, can you, in the screenshot? So I'm just going to skip that. So organization within the repo. So this is the stuff that I kept talking about how. And this is why I decided to do my talk on Terraform with Git, is because of all of those problems right at the top of the talk about Terraform. Hopefully, some of these examples now will show you what I'm kind of getting at and what I'm driving at, and why I think this is quite an important thing to get right at the beginning, because you can end up with giant repos, lots and lots of work, and the idea of porting them into some other much more sane structure becomes an absolutely huge job, partly because every single one of these repos represents deployed infrastructure that people are using. So, if you migrate, something goes wrong, your state file gets screwed up, suddenly all the Jenkins servers are going to be 10 times harder to upgrade, and all your plugins are going to be horrifically insecure, like overnight. But anyway, so this is the first stage, I'd say, of like most people's experiments with Terraform. So it's sort of following the documentation. See if I can show you a bit more about what it actually looks like in here. So this is just, oh no, we can't because the screen's too small. Oh well, okay. So hopefully we can get to the point where you can see a little bit. There you go. So that's what Terraform looks like for anyone who hasn't seen it before. So quick skim through this. This is our provider block. This is telling Terraform that we're going to be using GCP. This is the name of our project. So literally project equals region equals zone. Hopefully it's pretty self-explanatory. And so you've got these resource blocks. And the cool thing is that the outputs of some of these other resources can go as inputs to your other resources. So I'm saying that this Google Compute Firewall needs to tie into this network that I've created up here. So that's really quick how Terraform comes together. But anyway, on this, you can't see it, but it's all in one file. So that's quite good if you've only got a couple of different bits and bobs, and maybe you're just first explaining it and you're first experimenting. What tends to happen next is you move on to reading about a thing called Terraform modules, which is where actually it becomes a useful tool. And this is when I started getting really excited about it. So you can basically create these blocks of reusable infrastructure here. These are where all your resources are defined, and you define some input variables for it, and you can then source those in another file, and you can say, right, in my dev file I'm going to source the module, and this is where it comes from. And so instead of having to write hundreds and hundreds of values every single time and rewriting the same stuff over and over again, you're just sourcing modules each time. In case, say, like, I want to do this network with this subnet, and then I want to do another network with a different subnet in a different region, and you'd just be changing the variables. The modules will then stay exactly the same, hopefully, so they can be, you can have like a pre-built config. This is how we do load balancers, and every time you're sourcing the load balancer module, you're just changing the small parameters, but you know that you're getting something that will work with the rest of your infrastructure. So that's the second stage, and that's okay. I've seen people get all the way up to production with that all in one repo with hundreds and hundreds of modules, with all of their resources and all of their everything defined in the one place. It works for them. I would suggest it's not the right way to go, for a number of reasons. Partly because it becomes more difficult to work out what's deployed where when you've got a lot of infrastructure going on. A lot of these examples that I've used today, because I had to write all of this from scratch, I've used very small examples, but you've got to try and imagine this when it gets to hundreds and hundreds of modules and lots of environments and different clients and what have you, and all the different kind of changes that need to happen and tweaks for that client and that client and that client. So when you want to tie them to specific versions of the modules, it becomes a bit more chaotic, using the tags that I was talking about earlier. So the next one is where things start becoming a bit more sane, in my opinion. So in the third stage, we're going to start separating all the repos out. So we've got a separate modules repo, which would contain all of our different modules. So we've got ones here for AWS, we've got ones for GCP, and at this point in time we can start making use of the versioning, the semantic versioning and the branching and the GitHub branching that I was talking about earlier. So every time one of these gets updated and you do a pull request that takes your code back into master, you can create a tag on the master branch, and what that allows you to do is when you source the module in your environment code, or config really, you can't see it, it's off the edge of the screen. Never mind. Anyway, trust me, there's a little question mark ref equals, and it'll say v1.0.0. What this means is that you can know that every time you run this config code, so for example, if you were to tie this into your Jenkins server, and so Jenkins goes, right, something's been updated, I need to rerun all of my environments again, you know that this, as long as that semantic versioning thing that you can't see doesn't change, you've always got deployed infrastructure. What this means is that you don't get engineer Z over here updating modules and then all of your infrastructure starts breaking and everyone has to drop tools and start updating everything all over the place because all the modules in the back end are changing. It's like, I don't know, I'm trying to think of a good example. It's kind of it's a funny beast because everything represents deployed infrastructure. It's hard to necessarily tie it back sensibly to things like Python modules or something, unless you were kind of constantly doing stuff with those. Anyway, so at that point in time you've got a full modules repo, you've got all of your modules in one place, and it's working okay. You can keep going like that for quite a while, but again you've got this problem where you've got all of these semantic versions, especially when you've got lots and lots of modules, you've got big teams, you might have more than one team. They're all tying into that modules repo. It's being updated all the time. You might have 6 or 7 teams that are sourcing from that repo as well. And again, if you've got just the semantic versions to go on, it can be quite chaotic trying to work out what's deployed where and what's being sourced from where. So one of the things that I've been doing very, very recently in terms of what we've been doing in WebEx is separating out some of the really important modules into their own repo completely. So this is where we get to the point where it gets really, really granular, and you can start adding all sorts of things. So you can add testing just for your infrastructure code, and you can run Jenkins files just for that particular module. So you're starting to treat then your infrastructure code exactly the same way that you would your application code, because it's stuff that's going to run in terms of like your production environments. It's going to affect your clients and the uptime of your services, and it's important to try and keep this stuff in check. Trouble is that it's infrastructure code, so it comes with another caveat in that this stuff costs money. So although all the things that I've spoken about today are using Terraform open source, the development of Terraform I found can be surprisingly expensive, simply because the whole way through the development cycle you're deploying infrastructure, and all of the best testing models that I've come across that work for Terraform do exactly that. They deploy infrastructure, check that it works, they tear it down again. But if you've got that going on, you need to just be aware that, for example, this is deploy networks. Networks are free. If you've got one for a database server, though, you could have a database server going up and down, up and down, up and down constantly, which is great. I mean, it's cool. It's what you can do with the cloud, but we can't start the presentation again. That's probably no bad thing. No, F5 doesn't work anymore. Cool. So yeah, we want to get to the point where everybody gets a repo, and then we can start testing things. And then at that point in time, so like in that example, I've got a Docker file because the testing framework that I use is TerraTest, which is a Gruntworks project. And then inside our Jenkins, we might not have Go installed, so you need a Go environment. So we've got the Docker file, so you end up with all of this stuff. If you've got all your modules in one place, it starts to become quite unwieldy. And the other part of it is that we want to kind of end up with this scenario, and this is where something like Terraform becomes incredibly powerful and incredibly useful. So when we've got separate modules to control each different sort of layer of our infrastructure, we can start getting to the point where our network team build the automation and the module for the network, and make sure that works, keep on top of the changes that need to happen, because quite often you'll find in modern services the network needs to tie into all sorts of other things in different data centers all over the place. So this can be its own thing all on its own. The ops team might be dealing with the VMs that sit on top that help it to do the rest of it, that do the routing or the whatever else needs to happen. And all of these at the top here, they're all modules. So one of the things that I was doing in a previous role was we were setting it up with our security team so that they had to be one of the approvers on every single pull request going into master. So they were trained up as much as everybody else, so that they understood everything that was going on. They knew exactly what firewalls were being updated. And this is one of the great things about having your infrastructure code checked into Git, is you get it kind of baked in, who approved it, who wrote it, who changed it. And you can keep an eye on all of these open ports and ingress and egress and all that kind of good stuff. And all of that kind of ends up with some stuff deployed somewhere that's running a service. So it feels like quite a lot of faff, but the whole point is that you get a good, secure service out the end of it that keeps everybody happy, or stops people being sad, at least. So a screenshot of the 4th stage, and there's some screenshots of VS Code there that no one can read. So. Cool, yeah, and that's what you start ending up with when you get to the end of it. It just gets bogged down with all sorts of crud. So this is a really terrible slide, but what I'm trying to get to here is that we've got our pipelines for our software going across the top here from dev to UAT to prod, and what we suddenly need to start thinking about is the pipelines that are going to be leading up into each one of these environments as well. And so you've got this kind of crossover point, And it's totally up to you how you want to approach each one of these, and if you want a separate one for DevUAT prod, or if you want, like I've got here, all sorts of different things going on. But it's an important kind of thing about the way that these things run nowadays. But yeah, I gave up trying to diagram that in any way that made sense.